Hello and welcome back. In this video we're going to be looking at the wheel case. This is a gearbox which takes its drive from the back of the crankshaft and distributes that to almost everywhere in the engine except for the propeller shaft drive. We'll have a look at what all those drives actually do and how they work, and then reassemble it and fit it onto the engine. So the first stage of the drive into the wheel case is achieved with this torsional damper assembly, which I referred to in the last video. They call this the spring drive. So there's an adapter that pushes into the back of the crankshaft with two different splines in it. This is the torsion shaft itself, which is allowed to twist, a little bit made of spring steel. So it's driven from this spline in the crankshaft, and it drives all the way along this shaft and actually couples with a spline at the end, which allows this to twist inside the drive shaft. In addition to this, in the event of this spring drive breaking, which they can occasionally, this bronze bush engages with the back of the crankshaft there. And there's the second spline, which allows a certain amount of angular movement, like that. So if that shaft breaks, the engine will still drive this shaft as such. So there's the input bevel gear here. As I mentioned before in the other video, this is the first stage drive for the supercharger, and this shaft is actually not really specifically part of the wheel case, it just drives through it, but this gear is. And that meshes with the lower and upper vertical drive shafts in the wheel case. There's also a master spline, you can see here where they've left one of the splines missing on that end of the shaft, and the same effect just on part of this end. And these engage with features in both ends of this assembly, and you can just see, hopefully, you might just be able to see it's achieved in the back end by this little pin which is pushed in from outside. Why do I know so much about this? Right, so on my ground running engine, that pin was missing when I first built it, and I wasn't aware of this. So the purpose of the master splines is to make sure that this is sitting halfway like that, to allow the thing to twist in both directions by that much. So when I assembled the engine the first time round, there are actually, because of the number of splines on here, there are actually 3 different positions you can potentially assemble this in. One of them is the correct one in the middle, then right up against one edge just about, and then right up against the other edge. So the engine was assembled with it up against one side. So I had a problem later on with the starter engaging dog, which we'll see later on, which is part of the wheel case. When I dismantled the engine after about 200 hours, every single one of these bolts here, which holds this gear onto the tube, had sheared off. You can see the nuts just on the back there. They'd all come apart, fallen into the bottom of the wheel case, and amazingly none of them had gone through any of these gear teeth, so that was lucky. And that goes to show you that this shaft is actually doing something, damping out the torsional vibration coming from the crankshaft. Because without it, if you've got a solid drive, which is basically what I had there, it shows you, you know, in spite of the fact that these are 1/4 inch bolts, and there are quite a few of them, that isn't enough, and they actually sheared. So the engine carried on working by virtue of this limiting spline in here, of course, it was still able to drive. So at this point, some of you are probably thinking, if these bolts shear around here, then therefore this gear can't be driven and the supercharger can't be being driven. But in fact, either by design or by default, it's got redundancy built into it, because the spline, the coarse spline in the end of here, will continue driving this gear. The quill shaft engages with a spline which is actually machined into this gear. So if this flange joint breaks here, everything still turns. Clever or what? So all the drives are taken from the upper and lower vertical shafts in here that come from the central bevel gear. So the lower shaft drives the fuel pump on the side, the coolant pump underneath, and then there's a transfer gear that goes on the front here. That drives through to the oil pumps in the sump, which we saw in an earlier episode. And then in addition, in the sump there's a drive for a hydraulic undercarriage pump. The vertical shaft here is the skew gear that drives the magnetos, which go on either side, which we talked about before. Then on the top we've got another set of bevel gears with shafts which drive up to the camshafts. In addition to the two single overhead camshafts, you've also got power takeoffs in 4 places, so 2 on the rear of each cylinder head, which can drive air compressors, hydraulic pumps. One of the air compressors can be for the autopilot system. So there's quite a lot of stuff being driven off here. I talked previously about the magneto skew gear and the problems I had with that. There is another skew gear on the lower vertical drive shaft, and this is the one that drives the fuel pump. This particular gear is made of aluminium as opposed to bronze, and it engages with this gear on the fuel pump drive, which then engages with the side of the wheel case there. And here are those 2 cam drive bevels. They're actually called the lower camshaft bevels because there's another pair up on top of the engine driving along the camshaft. There's a top cover that goes on there. It's got an oil feed here. This is one of the things they introduced when they were having problems with the skew gear, and they put an oil bath underneath the magneto gear, and the rest of the lubrication in the wheel case is all splash. So the cover goes on there, and here is one of the vernier spline camshaft drives. Now we're looking at the underside of the wheel case. Here's a view of the coolant pump drive. This is the face which attaches to the engine, and these features on either side here are the oil drains back into the lower crankcase. This opening up here is for the 2-speed supercharger changeover cylinder, which is an engine oil driven hydraulic cylinder. This flange up here is for the supercharger. Now the starter motor is fitted effectively vertically on the engine underneath this point here. Here is the starter motor. Now I haven't touched this because I've had a few questions about, it's quite heavy, what things on this engine were like before I cleaned them up. So in a future video I'm going to take this thing apart. It doesn't turn by hand at the moment, not surprisingly, but just see what it's like and hopefully rebuild it into working order. It looks like it should be okay actually, and possibly one or two of the other bits of the engine so you can see what it was like. The starter then drives into this epicyclic or planetary reduction gear with a ratio of about 21:1, so there are 2 stages in there if you look at that, and it's connected to the starter motor by this quill shaft which goes down the middle of there. So if I rotate it by this shaft, hold on to that housing, you can see sort of reduction ratio. There are 2 bevel gears on here. One of them engages with the engine down there, so there's a lay shaft, and this one here is connected to a hand turning gear. Now this is a one-way drive, I don't know if it's possible to see in there. It's got angled rollers, and I can turn it one way but it won't reverse, it locks up solid in reverse. It's a bit like a ratchet, but it's called a sprag clutch, and in fact these things did tend to overheat and wear out in service, and they replaced this with a physical spring-loaded ratchet later on. Interestingly, some aircraft have a placard on them, possibly in the cockpit, I'm not sure, that tells you that if you're going to use the hand turning gear for actually attempting to start the engine, which I can tell you is very, very difficult because I've tried it, that you have to tie the ground crew member to the undercarriage leg, because otherwise, basically at a ratio of 15:1, which is what you've got here, it's still actually quite hard to turn the engine through compression because it's got such big cylinders. And as soon as the engine fires, there's absolutely nothing on this handle at all, it's just completely freewheeling, and there's a very, very strong possibility that the poor ground crew member is going to end up in the propeller interesting, but it was never actually intended as an engine starter. Of course, it really would be an emergency thing, that. So this goes into the side of the wheel case there, and there's a cover that goes over it. And in some power plant installations, I have an extension tube on here just to bring this coupling out to the outside of the cowlings. So the lay shaft then drives through to another spur gear, which in turn drives a larger spur gear containing a multi-plate overload clutch to protect against the engine trying to fire backwards because of the ignition advance, and particularly the fact that these engines start with a booster coil, as I'll explain in another video. And you don't want the engine trying to turn the entire starter mechanism in reverse, particularly with such a high ratio. And in fact it is stopped by the sprag clutch that I mentioned earlier, so that locks up and this clutch will then slip. And you see it sometimes when you watch these aircraft starting on the ground. The propeller will go around and then it'll either just kick back a little bit or it'll just stop dead, and then the starter will go again. Once the compression dies down from the cylinders, you can press the starter again. This clutch then goes on there and it drives this Bendix mechanism, which is the engaging mechanism. So there's a little tiny multi-plate clutch in the back of here which is held stationary by being attached to the wheel case. So if I rotate this gear, the Bendix then comes out and engages with one of the first stage supercharger shafts, which has the same dogs machined onto the end of it. Once it reaches that point, the gear keeps on rotating and it's held in the out position by the action of this very small multi-plate friction clutch in the middle here. And here is the first stage shaft with the dogs on the end of it, and actually this is prior to being cleaned up, so you can kind of see they're just very oily. You get a lot of black oil because of the combustion deposits going into the oil, but in fact, as you've seen with a lot of the other parts, these parts are cleaning up really well. So I mentioned earlier that I'd had a failure of this dog on my own engine, and here's the front of the dog. This is what happened to it. There's a small sleeve incorporated into the back of it which had broken, and if you actually look at this dog, there's a spring behind here, and when the engine fires it can actually push the dog back like that. And one of the modifications they made to the Merlin during its production was to strengthen this sleeve. The whole assembly is hardened. It has to be extremely hard for this dog to work, and basically this is just very brittle and it can fail. That causes the assembly to jam up, so it'll either jam into engagement or it just won't engage when you turn the starter, which is what happened to me. The supercharger lay shafts, which we'll talk about in another video, engage. There are three of them. They engage with these three positions here, so the starter dog shaft is obviously there, and once all the engaging assembly is in there, then this housing goes in there, which has another roller bearing and an additional roller bearing inside it to support the front end of the Bendix. One more little interesting point about this small retarding clutch in the middle of here: it's got a threaded portion on the end of it which sticks through this hole in the wheel case. The stepped portion on it engages with a slot machined into the other side of the casing, and there's a 2BA split pinned nut holding this in place. Now, bearing in mind that these mechanisms can stick, I mean in particular if an engine's been inhibited or it's just got dried out oil in it and it's been sitting for ages and ages, then the mechanism doesn't necessarily come out because that's a fairly small clutch in the back of there. It can stick in place. So in order to get into there you have to remove the supercharger, you then have to remove the supercharger drive, and then you have to remove this wheel case from the back of the engine in order to actually access this nut, which is a bit I find quite amusing. However, on the very earliest engines you also had to remove the cylinder blocks because the upper vertical drives to the camshafts are enclosed in a tube to keep the oil in there, and there was no way of dropping that assembly far enough to remove the wheel case out from the cylinders. They cured this fairly early on. The Merlin is certainly almost unique in having the starter engaging mechanism inside the engine. It's very common practice really to have an electric motor like this one with a reduction gear, then the overload clutch, and then the bendix and the engaging dog on the end of it, which just bolts onto the outside of the engine, so it's a very easy assembly to remove and just swap or overhaul. The trouble is, this puts another 10 inches onto the length of the engine because it drives directly onto the crankshaft, and when you have inline or V engines like this one with a supercharger on the end of them, it then becomes very difficult to install something like this, and I certainly don't want the engine being that much longer. But I do wonder whether, in the design of this engine, whether they could have done something with this gearing here and had a starter like this running along in this space, which would certainly have simplified the wheelcase a fair bit. In fact, later on the Griffon engine, they fitted a starter of this kind of type right up at the front end of the engine, driving into a gear off the reduction gears. This area of the wheelcase here sticking out contains this shaft, which is driven from one of the supercharger first stage gears. Runs through there, has this gear on the front of it. The other gears which it meshes with are actually part of the crankcase, and then the generator or dynamo drive shaft runs along the side of the engine here. And the generator has a maximum speed of about 6,000 RPM, or twice crankshaft speed. In addition to the skew gear problems, they did also have one or two problems with this upper vertical shaft, because the skew gear itself is on a very slight taper, so it's a tight press fit onto the shaft, and it's got two keys to drive it. There's a bearing on the bottom of here, a ball race, and then it just had a spacer, a collar between the two. So at the same time as trying to clamp this bearing in position, you are also pushing this onto a taper, and the two things don't really align very well unless you machine it very precisely, because this is just going to get tighter and tighter, and it might be extremely tight or it might be quite loose before it starts to clamp this bearing. And then this was subsequently retained then with this left hand threaded nut. So later versions just used this pair of crossed parallel pins, and they're not exactly a very tight fit or anything in there. And this is a small clearance fit over the shaft as well. There's a gap underneath the skew gear, and the bearing itself was retained by a separate nut. Okay, so just before I start reassembling the rest of this wheelcase, I think you've been a bit short-changed because I didn't even pull all of it apart. These upper and lower vertical drive shafts, plus the cam bevels, were actually nice and free, still had oil in them actually, no graunchiness, no dirt in them, so it was washed through and absolutely fine. So I think it's only fair that I show you some of the tooling that I would have used if I was going to pull it apart and put it back together. So the first stage in removing these vertical drive shafts will be to fit this gag plate onto it, which bolts onto the casing like that, and it prevents these upper and lower vertical drive shafts from rotating, so you can unscrew the retaining nuts. The first one to come out is the lower shaft, so I'll get that way up. This is one off another engine. There's the lower skew gear which drives the fuel pump, and then the oil pump drive gear, and this is the coolant pump shaft sticking out the bottom of it. So there's this hexagon nut on here which you take off, and then that unit comes off the splines, so you're left with that in the engine. You then have to go up with this long socket up inside the casing, which unscrews the bearing retaining nut, which is this component here. So that comes off, retaining nut comes off, and then you can knock this through. This is the bearing housing, which is a close fit inside the wheelcase. That will then come out downwards, leaving you a big opening here. The next stage is to remove the retaining nut on top of the upper vertical drive shaft. Then you lift off this bevel gear, and it's got a set of loose bearing rollers with it. That comes out. Through the opening, we then go down with this socket, which unscrews the left hand threaded nut holding the skew gear onto the shaft. And a bit like me, it's losing quite a lot of its teeth now, this thing. Now, this special feature around the top of the skew gear is designed for this puller, which then goes down inside there. You screw this up, it basically closes itself around that feature, and then you're able to, using this bolt in the middle, you're able to extract the skew gear from its taper, and these can be extremely tight coming off the shaft. there'll be a ball bearing on here, which is another metric one. I've mentioned these before on the engine. And that's all that's left there then, so you're able to press this shaft out through that opening left by the lower shaft. The only thing left in the casing then would be the bearing itself, which is retained with this retaining ring, and there's another socket which goes down inside there to unscrew that. And one of the advantages sometimes of making your own tools instead of using originals like this one, that I was able to drill and tap the end of this thing, and I invariably had a plate underneath there to actually keep it all dead square while it's being unscrewed. And you know, you can see I've had Stilsons and things on here before, because actually these things again can be immensely tight sometimes, and they're just held in by a little locking wire. You can see the hole there, and that one for the lower bearing retainer. And then to remove the lower camshaft drive bevels, we have this tool which has a spline on it which engages with the middle of this gear, which will be a camshaft drive normally. Just sits on top of that, like so. You push that in, and then again, this thing would have been removed by this point, but the gear itself can't be rotated, and we go underneath in there with a socket, undo the nut on the bottom of it, and you can pull the shaft out. And again, the bearings, there are two sets of ball bearings in this particular engine in here, which are retained by rings a little bit similar to this, which then have to come out. So onto the starter drive, I'm going to feed this Bendix engaging mechanism back down into here, into its roller bearing. So now there's just a little 2BA castle nut to fit onto here, which is the one I was saying you can only access by removing this casing from the engine. But I'm going to start by putting the split pin through there, just to show me where it is, because once the nut's on it's not really easy to see, so we know it's somewhere there. And I'll leave it on because otherwise this stud can push back into the casing again. There we go, take it out. There. Quick correction, I actually had the key feature on the end of the Bendix aligned the wrong way with this wheel case, and it's just as well I noticed actually, because it would have rotated as the starter was turning, so the split pin actually ends up horizontal, and then you get room to put a washer behind it, so I kind of knew something was going on there. So the next stage is to assemble this roller bearing into the bearing housing, which will then put into the wheel case there. Right, so I've fitted these rollers into the cage with grease, help keep them in place. Now I'm going to get the housing, which I've also greased. I'm going to put that over the top of there. So the bearing is now fitted in there, and then we're going to put this in the casing. There we go. Okay, so now we start with the main reduction gear housing, and the second stage gears are in there but not the first ones. So put that on there, put these two holes to line up here as well. Then put the next stage to go in. Like so. And then finally the cover. And these two little retaining screws. So that when you remove the starter motor, none of this stuff falls out, because obviously this is underneath the the wheel case when it's fitted to the engine. So now I'm just going to run this with a drill, make sure the mechanism goes in and out okay before I put the hand turning gear on, because once that's on it'll only rotate one way. And finally the hand turning gear. And there we go. Lovely. So that's the wheel case finished and ready to go back on the engine. There's this little breather here above the hand turning gear which goes back to the oil tank. The oil tank itself doesn't have an atmospheric breather on it, so as the oil gets used, air comes back out of the engine, fills the oil tank back up again. There is only one atmospheric breather on the engine, and that's at the front of the crankcase. The little gear drives the oil pumps, now fitted. And useful bit of information here if you're researching engines which have been excavated out of the ground from crashes. This is one of the components that has the engine number on it. You can see there it's 54967, pretty much always anyway. And here you can see the two gears which run through to the generator drive on the side of the crankcase, which is driven by that shaft I put together earlier. There we go. So this is quite a milestone in the build really, because everything else that goes together on this thing goes on to what you see in front of you. Cylinder blocks, the camshafts, the blower drive, the blower itself, the carburettor, this pile of really filthy pistons in front of me because they do get quite oily. I'm not looking forward to cleaning those up, but we'll see what they look like before and after. So if you're enjoying these videos, please feel free to subscribe to this channel and see what I get up to next time. Thank you.